Very good morning, students. Today we will start our lecture 8 part 2 on indirect method of soil moisture measurement. As you all know that in indirect method, we have different instruments to be used for measuring the soil moisture such as tensiometer, gypsum block, neutron moisture meter, time domain spectrometry, and even pressure membrane apparatus. In this way, we use different devices in case of the indirect method of soil moisture measurement. In that, the first instrument used is the tensiometer, or we also call it as aerometer. It was given by Richard and Gardner in the year 1936. Richard and Gardner developed this instrument, and this question was asked in ERS 2025. So it is an in situ measurement of soil moisture. We measure the moisture in a field condition by placing these sensors in the soil, and the principle behind that is water moves in and out of a porous cup depending upon the moisture content in the soil, creating a partial vacuum in the gauge or a scale tube. This is the soil tensiometer. We call it as aerometer. This is the porous cup and this is the cap. So this instrument is suitable up to 0.85 bar tension, 0.85 bar atmospheric tension. The tensiometer consisting of a porous ceramic cup filled with the water. We can open this cap and we have to fill this with the water, and then connected to a water filled tube, which in turn connected to a pressure vacuum gauge. And the scales are calibrated in 100 of atmosphere. You can see here the scales are either in centibar or in a bar. 1 bar is 100 centibar. So this is a tensiometer. The tensiometer has a gauge. It has a gauge. It has a porous cup. It has a plastic tube which is filled with the water. There's a plastic tube which is filled with the water. So the material required for this particular experiment using tensiometer is required tensiometer, cool distilling water, inserting tool, and wet cloth and a hammer. What we have to do? We have to generally we have to take a small hole inside the soil where moisture has to be measured. We have to install this tensiometer and cork it tightly with the screw cap. You have to tight this screw cap after filling with the water. After filling as above, hold the tensiometer cup above a hot plate. As the moisture evaporates from the cup, the needle on the vacuum gauge deflects and shows a increased tension at least up to 0.85 bar atm. And is defective, the needle will come back if it reaches 0.85 bar. And the installation of this instrument, bore a hole into the soil within effective root zone. If this is the root zone of the soil, we have to bore near to the root zone by using a hollow pipe or inserting a tool. Then insert a tensiometer into the resulting hole to ensure the proper contact of the bore. The tensiometer shows real 0 if there is a free water. If the water contained in the soil is there, the water contained in the porous cup cannot ooze out. So it shows 0 deflection here. If moisture contained in the soil is dry, water oozes out from this porous cup and there is a deflection in this particular scale. And at field capacity, you can see the value of up to 0.3 bar or atm. The precautions has to be taken while using this instrument. What is that? First, do not touch the tensiometer cup because this is very porous. If you touch this, the pores might get blocked and water cannot ooze out. Then second is, do not allow the cup to air dry. So you should not allow this cup to air dry. And occasionally, tensiometer should be refilled with water and soil moisture gauge in order to give a proper reading. You have to refill this water in order to give a proper reading, or else it will not show the exact value of the soil moisture tension. And when you are placing this in the field, you have to place this such that you should be protected from any animals. So the next is the tensiometer will deal with individual. We will deal with the gypsum block, or we also call it as resistance block. The gypsum block is also called it as resistance block. Yes, this is the instrument and this is the gypsum block. What it is, it was developed by Boykos and Mick in the year 1940. The resistance block works on the principle that flow of electricity between the two electrodes, we consider this is a two electrode, the flow of electricity between two electrodes in a porous block embedded in the soil depend upon the moisture content in the soil. So the flow of it is the Boykos current meter. When electricity is passed to these electrodes, the flow of electricity between these two electrodes is directly proportional to the moisture content in the soil, and the resistance of the flow of electricity in a porous media is inversely proportional to the moisture content. The resistance, sorry, I was talking about resistance. Resistance is inversely proportional to the moisture content. Conductance is directly proportional to the moisture content in the soil. Generally, at field capacity, the resistance or shown by this block is around 400 to 600. It means lower resistance. But at the permanent wilting point, the resistance shown by the instrument, it is around 50,000 ohms. This shows that higher the moisture content, lower is the resistance, lower is the moisture content, higher is the resistance. So this, if you see these blocks are electrode is made from a plaster of Paris, and collected through a wire which is connected to a Precautions. So the name indicates because it was developed by Precautions and Mick. So this is the instrument. We generally place this instrument and electrode inside the soil, and we connect it with the Precautions. It will give you a moisture content in the soil, which is directly proportional to the conductance and inversely proportional to the resistance. The next is how to prepare this gypsum block. Just take a plaster of Paris and take some molds and place the molds and few wire electrodes. If you connect it, the plaster of Paris gypsum blocks are ready. The next, how to install this. So the procedure is that the sink or a bore with a post hole agar to depth of installation. It should be in the root zone. Place the block inside and close to the bore in a small portion, tapping the soil with a metal rod. So you have to tap the soil with a metal rod. Then fill the block whole bore with the soil in a natural order. 3 to 4 blocks should be placed in each bore at a different depth, and ensure the resistance with the help of a Precautions. When the resistance comes to the recommended level, irrigate the field. See, if the resistance is around 400 to 600 ohms, it is under field condition, you need not irrigate. If the resistance is around 50,000 ohms, that condition where permanent wilting plant, you have to go for irrigation. The next is a Neutron moisture meter. So this is one among the modernized moisture measuring instrument, where we use the neutron source as the radium and beryllium and mixture of americium and beryllium, the neutron source, that is 2 to 5 millicurie of radium and beryllium and americium and beryllium. The principal component here, it is a probe to be introduced source of fast neutron and the detector of slow neutron at a desired depth. This is a probe. You have to place this probe in a desired depth. A scale or a rate meter to monitor the flux of the slow neutron, which is proportional to the soil moisture content. When you are using and releasing the fast neutron, such as radium and beryllium, americium and beryllium, which hits the water molecule and slow down, and the amount of slow down molecules is the soil water content in the soil. The fast neutron source is used as radium and beryllium, americium and beryllium. Through improper use of neutron moisture meter can hazard us with the hazardous. So while using the neutron moisture meter, a reasonable or more care has to be taken, because the radioactive source which you are using, such as radium, beryllium, it may harm to the human being, right? So you have to use it cautiously. So this is the neutron moisture meter. How it is there? A probe is there. This is the probe. A probe is installed in the soil. In that probe, we are releasing the neutron source. This is the radioactive source, such as radium and beryllium, americium and beryllium, and it is connected to a digital meter. The fast neutrons are released into the soil around 15 centimeter in case of dry soil, around 45 centimeter in case 15 centimeter in case of wet soil, and the 45 centimeter on dry soil, which detects the water and gets slowed down. That slowed down water is detected by the boron trifluoride, which is detected in the particular instrument. This is detected in a particular instrument. This instrument looks similar to this. This is a probe. This is a time domain refractometer, but the probe is quite similar to this. The next, we have pressure plate membrane apparatus. So this is a laboratory method of soil moisture measurement, which was developed by Richard and Spearman in the year 1941. The pressure plate apparatus is generally used to estimate the soil moisture constants, such as field capacity, permanent wilting point, moisture content at different pressure. The apparatus consisting of a airtight metallic chamber in which porous ceramic pressure plate is placed. Generally, a pressure plate in which the soil sample are placed. Then the pressure plate and soil sample are saturated and are placed in a metallic cylinder or chamber, and required pressure, say at field capacity 0.33 bar, at permanent wilting point 15 bar is applied through a compressor. Then the water from the soil sample, which is held at a lesser than the pressure applied, trickles out and the outlet till the equilibrium against the applied pressure is achieved. After that, the soil sample are taken out, oven dried for a determined moisture content. This is a procedure how pressure membrane apparatus looks. This is how it looks. So this is a chamber. This is a chamber in which we have a ribbon on which the soil sample are placed. So you have to saturate the soil sample and you have to place it. Then we close the lid and we apply a pressure to an extent. At what condition? Whether it is a field condition, field capacity condition, 0.33 bar pressure. When it is a permanent wilting point condition, we have to apply at 15 bar condition. Moisture gets oozes out and come out through the outlet pipe. So we will determine the amount of moisture content in the soil at that particular pressure. Laboratory method of soil moisture measurement. Then we have TDR method, time domain refractometry method. This is mainly based on the what principle? Mainly the dielectric constant. Dielectric constant. What is dielectric constant? The higher the dielectric constant of the soil with the transmission line, the slower the speed of voltage plus. So based on the voltage passing through the soil, it determines the moisture content in the soil. This is how we generally call it as neutron probe meter. This also works based on the TDR principle, time domain refractometry. So generally we will place this inside in the soil wherever you want to measure the moisture content, and you have a readings here. Just on it and check the moisture content at different places of the soil. The most handy method of measuring the soil moisture, and it gives in a volumetric moisture content. That is in a percentage volumetric moisture content. Generally, a parallel probes are separated by 5 centimeter and vary in the length of 10 to 15 centimeter. The sampling volume is generally a cylinder a few centimeter in radius around the parallel probe. The coaxial cable from the probe to signaling process unit should not be longer than 30 centimeter. So yeah, this is the probe. The probe, how it looks. So these probes are inserted into the soil and we measure the moisture content. If you see there, the water content has a dielectric constant of 80.4% and that of air is 1. So if it is, we are placing in air, it shows only one value. If you are placing in a moisture, it shows a different value based on the volume percentage. It gives you the moisture reading. So these are the few indirect method of soil moisture measurement. If you are liking my teaching, please hit a like button and subscribe my channel. Thank you.